Now, in calculus, you learned that about area under the curve. In statistics, we are going to use the fact that if the area under a curve adds up in total to 1, then the probability is the same thing as the area under the curve. So let's take a look at example 1 here. A random variable x has the uniform distribution on the interval 0 to 1. The density function is f of x equals 1 if x is between 0 and 1, and f of x equals 0 for all other values of x. All right, so let's notice a uniform distribution is just a horizontal distribution. And so notice that it's, in this case, a straight line at y equals 1. And if we look at it between 0 and 1, and we think of area under a curve, we think of this area right here between this line and the x-axis. This is a rectangle. And if you think of your area of a rectangle as length times width, this is length 1 and width or height 1. 1 times 1, the whole area is an area of 1. So let's notice for 1, 2, and 3, we want to find the probability that x is greater than 0.75. We want to find the probability that x is less than 0.2, and we want to find the probability of x being between 0.4 and 0.7. Now, we're just going to use the idea of area under a curve. And I'm going to use my little draw feature. Now let's notice x greater than 0.75. So I'm just going to estimate where 0.75 is on the x-axis. We'll just say right about there. 3/4 of the way to 1. Okay, now we want the probability that x is greater than 0.75. So we're looking at this area right here that's greater than 0.75. So let's notice the distance from here to here is 0.25, and then the height of that rectangle we just made is 1, and 1 times 0.25 makes this probability 0.25. All right, now let's take a look at 2. Let's find the probability that x is less than or equal to 0.2. So I'm going to erase the picture that I have there. And let's put a 0.2 on there. So 0.2 is somewhere in here. And we're looking at the probability that x is less than that. So, and I'm not drawing very straight, but we're looking at this rectangle right here. So again, if we think of this length is 0.2 and the height is 1, so 0.2 times 1, this probability is 0.2. All right, now let's look at 3. And again, I'll erase what I've got here. And we want to find the probability that x is between 0.4 and 0.7. So 0.4, I'm just going to estimate, it's right about there. 0.7, maybe right in there. Doesn't matter, I don't have to be perfect. So we're looking at the area, and I'm not drawing very straight. The area between there and there. And of course, if I were able to draw straight, those would be nice straight vertical lines. We'd have a nice rectangle there, and we're going to pretend that it's nicely, perfectly drawn. All right, so let's notice the distance, this length of this rectangle is 0.3, and the height, again, is 1. So it's 0.3 times 1. This is 0.3.